Answer to the bell ring is
12.5.
I agree with that. Does anyone have an answer number 2?
C.
It is C. How did you solve? Did you put it in y equals x plus b?
No, I didn't do standard form because I hate that.
At least the fact you recognize the different forms, I'll give you that. So you got y equals negative 2x plus 6. Yeah, good for you. Again, y-intercepts happen. That means x is 0. So if x was 0, I have 2y equals 12, so y equals 6. I don't write anything. 2y equals 12, so y equals 6. And x-intercept would be at 3. 4x equals 12, x equals 3. A little faster. I don't have enough time for all that. Your way will work. Time consuming. Okay, I'm running late this morning, not you. I wanted your graphs. If you haven't turned those 2 in yet, you need to get the 2 graphs to me from yesterday. I understand they were a little complicated. Sorry, I just picked old ones you've done before because I knew they were familiar to you. Today I'm a little more prepared, although I am running late. Okay, so on our first lap, we talked yesterday about standard form, it being ax squared plus bx plus c. You can wait till I stop talking. I would love you dearly if you would. Okay, and I was mad at you yesterday for not knowing standard form. I kind of made fun of you to 4th period because they came up with it. So I'm mad at you for not knowing standard form because we've been staring at it for 2 months at least. Okay, I threw a whole lot of stuff at you. We talked about how if you looked at the first term, you could tell if it opened up or down. We talked about how you could find that axis of symmetry using negative b over 2a. We talked about how that is the x-coordinate of my vertex. So I can plug that back in and find the y-coordinate. I have the whole ordered pair. We talked about if you factor it, you end up finding the roots, which is where it crosses the x-axis, or the zeros. And then we even discussed y-intercept, again, like with the bell ringer, is when x is 0. So if you plugged in a 0 to your function, what would you get out for y? And it's always easy to spot because you just cover up the 2 pieces with an x. It would be negative 3 for both of these, Natalia.
Are you taking the homework for, like, accuracy?
If you did it.
Your stuff I did.
Yeah, did you do it? Did you do the things I asked you to do? Did you try all these things? If you didn't try the things, then try the things and I get in talking. Try the things. Someone has tried the things. If you're stuck on the things, ask somebody when I get in talking. Okay, standard form is what we're used to seeing, but it's actually the hardest to graph from here, in my mind. Intercept form is a whole lot easier. And that's what we're going to talk about today. It looks like y equals a, x minus p, and x minus q. Or, as you're used to seeing it via the LTF lesson, in LTF, we didn't call it p and q. We called it r1 and r2. So p and q are the 2 roots, the way r1 and r2 are the 2 roots. But for some reason, I like the way LTF did it with r1 and r2. That makes more sense. But over the years, we've stuck to P and Q for so long that I have like a worksheet to hand you. They use P and Q. You're going to see it on if they asked about it on a standardized test, it would be P and Q. So at least once you know it's P and Q. It's just variables. They're still just standing in for the roots. Standing in for the roots.
So why don't you have like P1 and Q2?
P and Q are 2 different letters.
Oh, gotcha.
They could have done P1, P2, but...
Okay.
So 0.1, 0.2. But they didn't. They did P, Q, and then if it ends up being a cubic function, they'll throw in an R. Okay, so before we go crazy and start trying to factor stuff or whatever, because it's already factored for us, thankfully, on this, let's start with how does it open? Okay, so it opens up, and we know this because why?
Because the first term's bigger than
A is bigger than 0, so we know it opens up. And the A in this case is what number?
1.
1. It's an understood 1 in front. I'll write it in since we need to understand it. And then before we start talking about roots again, I know it opens up, so it's a happy face. I also need to know that axis of symmetry. What was the formula for the axis of symmetry?
Negative b over 2a.
Okay, so negative b over 2a. Oh, Lord, my life got a little hard. Where's the b? Where's the, I don't know what things are what. Well, we know that a is 1, we think. I know, this looks hard. So while I said we were going to axis of symmetry, we're going to come back to it in just a second. So I think intercept form is easier to graph. Is it easier to spot that axis of symmetry? No, because it's not the easy A, B, C thing. Okay, so we're going to come back to that. And then let's go on to our last thing, which is the zeros. Because an intercept form, well, the last thing we're going to talk about with this form, could we get the vertex? Yeah, we'll talk about that in a second. But what we're going to focus on are the intercepts, the x-intercepts. And what do we call those x-intercepts? They had a term. And zeros. Okay, so today we're going to discuss why we call them roots and why we call them zeros. Roots meaning talking about the graph. Zeros meaning we literally set our equation equal to 0 and we put each of our binomials equal to 0. Okay, so meaning I see y equals x plus 1, x minus 3. To find these zeros, you set your equation equal to 0. So you have 0 equals x plus 1, x minus 3. You end up setting each term equal to 0. So 0 equal to x plus 1, 0 equal to x minus 3.
Isn't it like always the opposite?
So it ends up being the opposite sign. It ends up being x equals negative 1 and x equals positive 3. Now, again, this is why we call them zeros, because we set the equation equal to 0 and we solved for x. We had 2 values. That's why they're called zeros. But if Natalia's caught on, it's always the opposite sign. So I should have already known. I see that plus 1. I have a 0 at negative 1. I see that minus 3. I have a 0 at positive 1, 2, 3, at positive 3. So I know where those zeros are. I know where those zeros are.
So how do we find the...
Now we've got to find some more things. How do we find that axis of symmetry from here? Ma'am?
I have a random question. Could you, since negative 1 and 3 equal out to be positive 2, could wouldn't 2 be b, and then you would write it negative 2 over a, which would be 1 times 2 would be negative 2 over 2. That's how I got negative.
Okay, and just tell me where it is then.
Negative 1.
Negative
I
1?
mean 1, sorry.
Okay, let me break her down for you. If she could see my key, it says exactly what she says. Here on Friday in Miss Compton land, that's deep. I'm just going to back to it. It's a parabola. It's symmetric. You know the 2 roots are here and here. So that axis of symmetry is going to be halfway in between them. So halfway in between negative 1 and 3 is positive 1. That's why my axis of symmetry is positive 1. This point is 2 to the right. This point is 2 to the left. Again, back to that golden part about an axis of symmetry, and our parabolas are symmetric. Symmetric. Now, back to what she said. If you like to show math on your paper, she took the 2 roots, negative 1 and 3, and she divided them by 2 because she was figuring out the distance between the 2. She's trying to, it looks like the midpoint to me. So she got 2 over 2, which is just 1. So if you're wanting to show work on your paper, her work is great. In my mind, I was like, well, I know 2 points. And I know the axis of symmetry has to happen halfway in the middle of those 2 points. Ma'am, you had a question?
probably was.
Okay, so if you can't follow her math, which is fine, back to you know where those roots are. You know that axis of symmetry has to happen in between, exactly halfway in between, because parabolas are symmetric. That's why I love them. They are symmetric. They make sense.
Does your line have to be dotted?
No, I always like to do it dotted. If I do it solid, people are going to think you're trying to graph a for real line. So I like to do it dotted. If you want to do it solid, it's not going to hurt my feelings. Okay, last thing we should probably do there, because right now I still can't connect the dots. I can't do some things I would like to do. I would like to figure out that vertex, and heck, I wouldn't mind knowing a y-intercept. Okay, so I want to do both. I'm that good today. So how do I find a y-intercept? We put x is 0. So we're going to do, if it's a y-intercept, that means x equals 0. So everywhere I saw an x, I'm going to put a 0. So I have 0 plus 1, 0 minus 3. I end up with 1 times negative 3. So that puts me at negative 3. Again, I plugged in 0 for the x's into my equation. So I have 0 plus 1, that's just 1. 0 minus 3, that's negative 3. 1 times negative 3, negative 3. So I know my graph crosses that y-axis at negative 3. But again, this is a parabola, and it's symmetric. So I know if there's a point here, there's got to be a point there too. And
What's the vertex going to be at?
you can make your life complicated, and you can actually solve for that vertex.
Yeah, 1, 5. 1 negative 5.
Or you can be smart and notice it's like it's showing us where that vertex is. It has to be right here. It has to be right there. And back to that tiny little trick I showed you yesterday. If your A is 1, positive or negative, and ours is, it ends up being from the vertex over 1 up 1, over 2 up 4. And if I wanted over 3 up 9, if I wanted to add more points, over 1 up 1, over 2 up 4, over 3 up 9. So I know I'm right. I could go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 if I wanted to add a couple more points. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so quadratics are squares, so they're perfect squares. If you know your perfect squares, over 1, 1 squared is 1. Over 2, 2 squared is 4. Over 3, 3 squared is 9. It works the other way as well because parabolas are symmetric.
Okay. You said those 2 concepts short.
But that only works if your A is 1. This counting trick will not work if your A is not 1. And then hopefully you connect the dots in a prettier manner than I did. My parabola graphing skills are getting worse and worse as we go in life.
I get that thing now where you added 2 squares. I just got it.
And that's how I check to make sure everything's legit anyway. Okay, we're going to do example 4. And when I say we, you're going to help me. So it opens down because A is less than 0 because it's a negative, so it's a sad face. Where are my roots or my zeros?
Negative, positive 1 and 5.
1 and 5. 1, 1, 2, 3, 4, 5. Can I draw today? 1, 2, 3, 4, 5. No, I can't. It's right where the arrow is. Okay, cool. 1 and 5. Okay, and then because I know all of this, and because the parabola is symmetric, where is my axis of symmetry?
2? No, 3.
It's a 3 because halfway in between 1, 2, 3, 4. I gotta put it here. But if you're like Kiana and you like to show some math for it, I'm doing 1 plus 5 and dividing by 2. 6 divided by 2 is 3. If that doesn't make sense to you, seriously, it has to happen halfway in between. Parabolas are beautiful because they are symmetric. There is no other function that is as much fun as a parabola with its symmetric qualities. Because you start getting higher powers and they start getting... parabolas are the best. I love parabolas more than I love lines. At this point, if you're able to do this part in your head from here on out, no. You don't have to. But, again, I don't follow you home, so I need Ty to be honest. If Ty's just using Desmos, there are going to be some things I'm going to be like, no calculator, no nothing. Just Ty brain. Ty brain only. So, as long as you are doing that in your head, good. If you're using something else to get those answers, we got a problem. Okay, we would love to figure out that vertex. We would love to figure out some y-intercepts or other things we would like to know. I would love to know that vertex. I would love to know the intercept. We know with the vertex, we know that the x-coordinate is 3. It's 3 something around there. So you could plug it in that formula and figure it out. That seems like a lot of work. I mean, I don't mind that. So y equals negative 3 minus 1, 3 minus 5. So I have negative 3 minus 1 is 2, 3 minus 5 is negative 2. So it ends up being a positive 4. So my vertex is at 3, 4. I plugged in a 3. 3 minus 1 is 2. 3 minus 5 is negative 2. Negative 2. 2 times negative, with that, it ends up being a positive 4.
Where did you pull a 3 from?
My axis of symmetry. The vertex is the only point on the parabola that crosses that axis of symmetry. So the vertex is the only one who's going to have an x-coordinate of 3. And you told me the axis of symmetry.
Yeah, I know that. So a flat point at 3, 4.
So 1, 2, 3, 1, 2, 3, 4. I got my axis of symmetry was 1. I plugged in the 1 to get the y coordinate. Yeah. My axis of symmetry was 2. I plugged in the 2 to get my y coordinate. That's when we're trying to find the intercepts. If I plug in a 3, I'm trying to find that vertex. If I plugged in a 0, like she's wanting to do, zeros make sense because intercept implies crossing an axis. So if I plug in 0 like she's wanting, I end up getting 0 minus 1, 0 minus 5. It ends up being a negative, negative 1, and a negative 5. So it still ends up being minus 5 because there's so many negatives. 1, 2, 3, 4, 5. And then we're questioning Miss Compton's entire sanity, so that was the y-intercept. We're questioning Miss Compton's entire sanity, and back to, I swear, if the a is 1, which it is, it ends up being over 1 down 1, over 2 down 1, 2, 3, 4, over 3, 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ask questions. Not psychic. Okay, so I think Natalia's mad at us plugging stuff in. You can plug in, if you plug in the axis of symmetry number, the x number, that's going to tell you where the vertex is, because the vertex is the only point that crosses that axis of symmetry. If you plug in a 0, that's going to tell you where that y-intercept is, because the x-coordinate is 0 when we cross that y-axis. So we're just trying to figure out more points on the graph. Heck, if I really wanted to, I could plug in 1 and figure out where it hits there. I could plug in 2 and figure out it's 2, 3. I could plug in 3, I figured out it was, I can plug in whatever I want for x to figure out an ordered pair for x and y, just like you had to do your entire life with an x and y table when you were graphing a line. In fact, in regular Algebra 1, they just make a table with like y equals x squared, and they just plug in 1. 1 squared is 1, 2, 2 squared is 4. Like they make a table when they graph these. And they never get to see the beauty of its symmetry. Thank you, ma'am. Stop. So if you want to make a table, just keep your mind right, you can. But I think it'll just slow you down in life. Okay, so we agree that our mind is blown, right? Blown. No?
Yeah.
Okay, so just like with a line, we spent a lot of time on slope-intercept, standard form, and point-slope form. There are 3 different forms of a quadratic. We did standard. That one was hard to read the zeros, but besides that, it's easiest to read because we're just plugging stuff in, chunking stuff out. I like intercept form best because it shows you the zeros. Like it shows you, these are my zeros, my roots are here. But as to finding the rest of the stuff, it might be a little, like Natalia's frustrated with this one, it's a little harder. And then what we'll handle on Monday is vertex form, where literally the vertex is shown to us. So if the A is 1 and we know the vertex, I use my counting method and figure out all the rest. Can I actually always calculate the y-intercept and everything else? Yes, I can. But if the A is 1 and I know that vertex, I count over 1 up 1, over 2 up 4, over 3 up 9 every single time.
What happens if you don't like either one of the ones you find?
You have to decide which is the lesser of 2 evils. You gotta pick something. Okay, so I had a feeling you would need to practice this, so I have one for you to practice.